Training in Weld Quality Assurance and Quality Control. Section 6, Non-Destructive Testing. Topic number 6, Principles of Radiographic Testing. The objective of this topic is to be able to identify the basic principles and applications of radiographic testing. Radiography is a very sensitive method used for detecting flaws found in castings, welds, and various metal structures. It is the most reliable form of non-destructive inspection and is used extensively in the welding industry for critical situations such as pipe welding and pressure vessels. The inspection method is similar to that used in hospitals to detect broken bones. The X-ray machine sends invisible radiation through the bone to a photographic film, similar to the film used in cameras. Since bone absorbs more of the X-rays than flesh, they show up lighter on the developed film. Breaks in the bone show up darker since more X-rays pass through at those points. Radiographic inspection of welds is done in a similar fashion, either with X-rays or with radioactive material called isotopes, which generate higher energy gamma rays. In addition to providing data for a more exacting evaluation, it also provides a permanent record in the form of a photographic image, or radiograph. As the radiation passes through the test item, the indication of the flaw shows as a lighter or darker area as compared to the surrounding metal. A radiograph of a piece of metal with varying thicknesses will show up on the film as variations in darkness. The image of the thinner material shows up darker, since it allows more energy to reach the film. Different kinds of material absorb different amounts of energy based on the material's mass or density. When the same intensity of radiation is used on aluminum and steel samples of identical thickness, the aluminum shows up darker because it is less dense and allows more energy to pass through. An internal flaw, such as scale, trap slag, or porosity, will also show up as a darker area on the film. However, care must be exercised when evaluating these indications, since images caused by dirt on the film, static electricity, or poor film processing may lead to the wrong conclusions. Because of many variables such as exposure, intensity of radiation, film processing techniques, and so forth, an image quality indicating device called a penetrometer is often used. It is usually a rectangular piece of material with the same radiographic absorption as the material being tested. They vary in thickness and commonly have 3 holes with different diameters. The smallest is equal to the penetrometer's thickness. The next largest is twice the thickness, and the largest is 4 times the thickness. In use, the penetrometer is placed on the object being radiographed, usually off to one side of the desired weld section. It shows up on the developed film as a slightly lighter area with one or more of the holes visible. The procedure will specify which hole must be visible for the required clarity to be met. Another device, called a densitometer, measures the film's density. This indicates whether or not the correct lightness or darkness of the film has been achieved in order to better detect flaws during interpretation. The success of radiographic inspection depends greatly on the training and experience of the operator. Therefore, it must be performed only by a qualified operator, not only because of the skill needed to correctly interpret results, but also because of the potential danger from radiation, which can cause serious injury or death if safe practices are not followed. Do not enter areas where X-ray or gamma ray sources are used without permission or supervision of an experienced radiographer. For gamma ray methods, the radioactive isotopes are always on, or emitting radiation, so that they must be stored and transported in special containers often called shielding pigs. These isotopes must only be used by a qualified radiographer. Radiation detecting devices such as survey meters or special film badges must be used or worn in order to detect radiation that could cause harm to personnel. In conclusion, all aspects of radiography must be handled only by an experienced operator who knows the importance of safety and has the skill to interpret results and maintain proper records to ensure quality inspection.